Hi everyone, in this video, we'll cover trigonometric transformation, a key technique for solving integrals with sine and cosine functions. When integrals get tricky, like sine squared x or sine x cos x, we use identities like power reduction, double angle, and the product to sum to make them easier to solve. Let's go over the key formulas you need to remember. Let's solve the first problem in trigonometric transformation, which is the integral of sine squared x. So we can't integrate sine squared x directly, so we have to use the identity, which is the power reductions, since it has an even exponent. So sine squared x is equal to 1 half 1 minus cos 2x. So substitute it here. So 1 half integral of 1 minus cos 2x. So we just substitute the identity. So now we have to split the integral. So integral of 1 and then minus integral of cos 2x. So what is the integral for 1? So it's x. So the integral for cos 2x is, we just have to divide it by 1 half, and the integral for cos x is sine x. So multiply this or substitute the 1 half in this expression, so it will become x over 2 minus 1/4 sine x plus c. So this will become our final answer. This is our problem number 2, which is the integral of sine x cos x dx. So when you see products of sine and cosine, especially sine x, cos x, there are usually two common methods. The first method is we will be going to use trigonometric identity, which we know that sine 2x is equal to 2 sine x cos x. So divide both sides by 2 to make it just like this. So cancelled. So sine x cos x is equal to 1 half sine 2x. So substitute this here, which will be going to factor out the constant, which we will be 1 half the integral of sine 2x. And the integral for this sine 2x is we will going to divide by 1 half. So 1 half the integral for sine x is equal to negative cos x. So this will be multiplied by cos 2x. So the answer will be equal to negative 1/4 cos 2x plus c. This is the answer if we are going to use trigonometric identity. So now we have to use the second method, which is we know that sine x, the derivative of sine x is cos x, right? So u is equal to sine x, du will be cos x dx. Cos x, divide both sides by cos x, so cancelled out. So dx is equal to du over cos x. So substitute the dx here. So integral of sine x cos x multiplied by du over cos x. So this will be cancelled out. So the remaining will be sine x. So right here we can use the power rule, right? So u, which is u raised to n plus 1 over n plus 1 plus c. So this will be raised to 1 plus 1 over 1 plus 1 plus c, which is can give the answer for sine squared over 2 plus c. So this will be now our final answer if we are going to use u substitution. So this our problem number 3, which is the integral of sine squared x cos squared x dx. So this is a product of powers of sine and cosine, and both are squared. So we can simply use trigonometric identity. And as we can see, it has an even power, which we can use the power reduction identity. So the value for sine squared x is equal to 1 half 1 minus cos 2x. For cos squared x, it is equal to 1 half 1 plus cos 2x. So if we are going to multiply this 2, this can give the answer of 1 minus cos squared 2x over 4, because this is a difference of square. So this is the integral becomes if we are going to substitute that value. So step 3, we have to take out the constant. So 1 minus cos squared 2x. So we're still not done because we still have a square of cosine that needs to be simplified again. So the value for this one, so cos squared 2x will be 1 plus cos 4x over 2, and substitute it here back again. So this will become 1 minus 1 plus cos 4x over 2 dx. So simplify the inside of the integral. So it's become 2 minus 1 plus cos 4x over 2. So 2 minus 1, so simply 1 minus, so substitute the negative sign here. So 1 minus cos 4x over 2. So don't forget that there is a 1/4 here. Let's delete this. So the next thing to do is, so 1/4 1/4, so multiply by 1/2 to take out the constant here. So the integral of 1 minus cos 4x, this will become 1/8. The integral of 1 minus cos 4x. So let's delete this first. So the integral for 1 is, this will become x, because the integral of 1 is equal to x, and the integral for cos 4x is equal to sine 4x over 4. So 1 8. So x minus sine 4x over 4 plus c. Then substitute the 1 8 for these expressions or use FOIL. Then it's become x over 8 minus sine 4x over 8 times 4. This can give 32 plus c. So this become our final answer. So let's solve the number 4 problem, which is the integral of sine cube x cos squared x. So we use trigonometric identity and use substitutions to simplify this integral. So first we have to split the powers to isolate one sine. So we know that sine 3x, if we are going to isolate it or split it, it can give us sine squared x multiplied by sine x. So the value for sine squared x is, in trigonometric identities, we know that sine squared x plus cos squared x is equal to 1. So sine squared x is equal to 1 minus cos squared x. So substitute this value for sine squared x. So it's become 1 minus cos squared x sine x. So my technique is we will be going to find the integral of sine x, this one. So dv is equal to sine x, which is the antiderivative of it is negative cos x. So let's change this and turn into negative cos x. So 1 minus cos squared x times negative cos x. So cos squared x times negative cos x, this will become negative cos squared x. Then, so in my case, we have to remove this one. So just substitute this negative cos cube x to this expression. So negative cos cube x, so there's exponent, so over 3 plus, because negative times negative, so become positive. So cos squared x multiplied by negative cos cube x can give us cos x over 5, because it has exponent of 5 plus c. So this will be now our final answer. So this is just my technique that I saw on YouTube. So let's solve this last problem, which is the integral of sine 3x multiplied by cos 5x dx. So when you see a product of sine and cosine with different angles, so this is the angles, we have to use the identity for product to sum identity, which is the formula for this, which is sine A times cos B is equal to 1 half sine A plus B plus sine sine A minus B. So now we have to substitute the angles for this formula. So this will be our A and this is our B. So let's rewrite again the formula, which is sine A multiplied by cos B is equal to 1/2 sine A plus B plus sine E minus B. So our A is equal to 3x and our B is 5x. So next, so 1/2 sine, what's our A? So 3x plus 5x plus sine our A is 3x minus 5x, then 1/2 sine 3x plus 5x, it become 8x. So this is 3x minus 5x will give us an answer of negative sign. So this will be negative sine 2x. So now this, let's substitute this, or this is our integral becomes. So let's remove this. So factor out the constant, so sine 8x minus sine 2x. So there's a dx. So integrate term by term. So that's the next thing to do. So the integral for this is 1/8. So what's the integral for sine x is cos 8x. That's why it has negative sign here. Then for this one, 1/2. So the integral for sine x is negative cos x. That's why it become positive. Cos 2x. So there's a 1/2. So substitute this 1/2 for this expression. So 1/2 times negative 1/8. So can give the answer for negative 1/16 cos 8x. So 1/2 plus multiplied to 1/2 is equal to 1/4 cos 2x plus c. So this is now our final answer.